Okay, so now what we're going to do is factor um, a slightly different problem. It's still a quadratic, but what's different about this is there's a number other than 1 here. And so that makes this more challenging. We refer to this as a does not equal 1. And so on the scale, you'll see something to that extent as well. So these are more challenging problems. The good news is that they're essentially the same as the first video for balancing the numbers and everything. The difference is we just might have more numbers to have to kind of scan through. So I'm going to start by making my box. Okay, and again, whatever is at the front, oops, I did the wrong color, shoot. Whatever's at the front goes here, and whatever's at the back goes here. Okay, and so I'm going to put those in. So we've got 2x squared and 5. And then how we figure out these two boxes is we're going to look at what multiplies to the diagonal. So we have to multiply, the combination of these two are what multiplies to 5 times 2x squared, which is 10x squared. And then the diagonal has to add to our middle term. If you watch the first video, this is going to seem identical because it is. The process is the same. It just feels like more to some people, so I want to address it. So it has to add to 7x. Okay, so to balance these things, I'm going to start with my combination of things that multiply to 10x squared. So I get 1x and 10x, negative 1x and negative 10x. And then I get 2x and 5x and negative 2x and negative 5x. So if I look at these, which one of these adds to 7x? That one does not, that one does not, that one does. And so once you find the combo that actually satisfies both of these things, right? It's got to satisfy this, multiply to 10x squared, but it's also got to add to 7x. So once you find the combo that works, you put it in these boxes. So we've got a 2x and a 5x, and I could have flipped these, okay? So just know that. And then what my job becomes is now I'm going to find my dimensions. Okay, so I'm just going to do it over here so it looks a little less cluttered, but this is just for video purposes, not for anything you guys need to feel you need to do. So 2x squared, 5x, 2x, and 5, okay? And so then I look and I say, what can I take out of both of these? Well, unfortunately, I can't take a number, but I can take an x. And then x times what gives me 2x squared? X times what gives me 5? If I took a 2x out of 2x, 2x times what gives me 2x? And that's 1. And then 5 times 1 better give me this, which it does. So then, again, this is a method, not an answer. And so my answer becomes these dimensions. So 2x plus 5 times x plus 1. Now you may be wondering, I mean, that's great. That is an answer, and Heather said so it must be correct. Not necessarily true, just in case you're wondering. But how do we check that? So what I'm going to do is I'm actually going to kind of cover up my work. And I'm going to look at this and I'm going to say, okay, if this is truly the answer, when I multiply it out, I better get my original problem. So 2x and 5 and x and 1. And I'm not looking at the rest of my work. I'm doing this in isolation. 2x times x, 2x times 1, 5 times x, and 5 times 1. And then I combine my like terms. And what I get is 2x squared plus 7x plus 5. And then I kind of open up to the problem again. Was that my original problem? And this better be the same as this. And it is. That means I got it right. So, of course, I'm checking that this works and makes sense. But at the end, another check, whether it's on scrap paper or on your actual work, you're checking to see if it multiplies out.